Hello and welcome to my exam 1 corrections. For this first one, I wasn't looking carefully enough, but these are going to be anti-parallel beta sheets because of that bond form. So when we're thinking about it, the strips are basically going like this, so the bonds line up, whereas in the parallel sheet, they are going all the same direction, and so they form bonds that are kind of angled like that. Here for 6, I just flipped these two around. I know that aspartate is polar negative, and the histidine is polar positive. From there, we have question number 10. This one I was thinking backwards, so this should be the correct answer, letter B, because it's lacking this phosphate group up here, and all of these will have only nitrogenous bases and ribose, no phosphate groups. Up here, I forgot about the I+4 rule, so we start with our initial, 1, 2, 3, 4. So this glutamic acid should be our correct answer, this letter C. Right here for number 17, I got tripped up on the pH rule. I couldn't remember if it was the pH was lower or higher than how that affected the protonation, but if pH is higher than the pKa, it's going to be deprotonated. And so the 3.1 and 4.8 are going to be deprotonated, whereas the 6.4 is going to be protonated. So the correct answer should be B. Then 18, in order for a dipeptide to be formed, water does need to leave. So it takes the OH group from the carboxyl and the hydrogen from the amine to get rid of it. It gets rid of the water, hydrolyzes it, and then there we go to have that bond. So it should be letter B right there. Number 19, I have looked at that and was getting confused with the sequencings, but it should be that this is a free 3 OH and 5 phosphorylated group. So the correct answer is A. Here on number 20, I believe it should be B rather than all of them are proper bonds, because the carbon group over here is not going to want to share this hydrogen, especially with like this water group. So the correct answer should be number B, letter B. Then over here we have the calculations. This first one, at what pH will the equal amounts of 1 and 2 of arginine be formed? It should be this pKa right here because it's in the middle of the groups. I was kind of just, guessing off the curve. Number 22 and 23, I have my calculations on the following page. So here I just got the ratio wrong. I wasn't sure how to bring it back from here. Also, I lost my worksheet, so I apologize. But here you take the Henderson-Hasselbalch and then minus the pKa, get this. Take the 10 to the 0.21, and that's where you get the base. So, and then you flip that around, so you have your 1.62 x plus 2, and that's going to give us our ratio here. Times that by 100, and it should be 38%. For 23, going off of that, I was unsure on how to get the 1.62 out of there, so you take the ratio right there, make it equal to 0.1. That's our acid, and then our base concentration over here. From that, we know that the pH is equal to the pK in this situation, and so we can just say that the 0.38 plus x and the 0.96 are minus x is going to be equal. Set them together, and there we go. That's the concentration of OH. The next two, I got just the 29 wrong. I was confused on how to proceed with this 1/20. So going there, there's my calculations. You can see it right over here. You get all this isotrate, correct? And then once you take that, you put it into the thermal equations. From that, I just used the ratio right into that instead of timesing it by this number by 120, so that'd be incorrect. What we need to do is just take it right into the equation right there, and that's how we get our answer. Following up, we have these two questions. So I started out here, used the equation, started over, but I was flipping things around, so I got the base wrong. This should be the base concentration right there. And then going from there, we had to get it into 1,000. I think I didn't do my conversions right, so originally, and then once we get here, you divide 1,000 by 2.274, you get 3.6, and then 1,000 minus 365 equals that. So that's how I get our concentrations and what they should actually be. And then our final ones, these two, honestly, I did all the work and I just flipped them around. Here you can see where I did all the work again, and I just had the acid and the base flipped around when I was typing it in. So those are my biggest issues, and thank you so much. Have a good night. Bye.